Welcome to weathering. What is weathering? Weathering is a term that describes all the processes that break down rocks in the environment near the Earth's surface. There are three types of weathering: mechanical weathering, also known as physical weathering, chemical weathering, and biological weathering. Mechanical weathering process tears apart rocks by breaking them by physically destroying them. Mechanical process physically fractures or pull rocks apart at a large scale or small. Let us take a look at a quick overview of mechanical physical weathering.
Weathering is the actual breakup of rock. You're going to change the size, you're going to change the shape. There's going to be absolutely no chemical change whatsoever with the rock. So anytime you see an example of like a canyon, for instance, the running water is going to break up the rock, transport it to another location, and eventually what's going to happen is that rock is going to be broken up enough where you're actually going to get a dent in the ground called a canyon. So the first type of physical weathering is what we call frost wedging. And this is basically going to be a scenario that's going to be found in many times up in the northeast part of the United States. It's also called frost action or sometimes called ice wedging as well. Water's going to work its way into the crack in the rock, it's going to freeze, and it's going to expand. As it expands, it makes the crack in the rock a little bit bigger. The bigger the crack gets, the more porous the rock is going to get, and eventually the rock is going to break apart. So you can see here the pen is in the picture, just kind of give you a little bit of scale. The crack in the rock, the water works its way into the crack in the rock, freezes, and expands. This is what we call abrasion. And this is going to occur basically with wind and with water. It's basically a general term for the rounding out of rock. Well, wind is going to cause abrasion in very dry climates by picking up sand fragments and sandblasting the rock and smoothing it out. Water just has a natural tendency to smooth things out as it flows over top of it. So what happens here is that the rocks round themselves out in a special type of weathering called spheroidal weathering. And what happens here is that the particles will tend to lose mass and tend to lose volume because of those sharpened angles tend to break apart. So here's some water abrasion, and here's some wind abrasion. So again, it's the smoothing out or the rounding out of rock fragments. Exfoliation is a type of physical weathering only found with granite. Granite is going to heat up and expand, it's going to cool off and contract. And thousands of years of this expansion and contraction, eventually what happens is that outer part of the rock, the outer layer of rock, will eventually break apart and almost peel apart, almost like a shell on a hard-boiled egg. So you tend to get these big slabs of granite that break away.
Abrasion is simply the mechanism of rocks breaking or wearing down by the direct action of other rocks. The rock falling down the cliff is undergoing abrasion as it tumbles down and breaks into pieces. Abrasion typically is strongest at the harshest environments. Ice wedging. Water expands when it freezes. It doesn't seem like much, but the expansion of water when it freezes is one of the most effective processes of mechanical weathering. Ice wedging is the process that is most effective in cold, wet climates in which there are many opportunities for freeze and thaw cycles with water present. High altitudes are particularly prone to such temperature changes. Exfoliation is a term that describes peeling of layers. In weathering, exfoliation describes sheets of rocks peeling off the bare rock face. Exfoliation of this sort tends to create a steppe appearance and creates landslide problems in many parts of the world. In environments in which temperature extremes are common, this expansion and contraction can loosen grains of rock enough to cause weathering. For example, in desert regions, the temperature may rise and fall as much as 40 degrees Celsius from night and day. This change is enough to cause measurable weathering over many years. Crystal growth happens when salty water gets into the rocks and later evaporation of the water produces crystallization in the pore or fracture space. Crystal growth works in similar fashion to ice wedging by pushing the grains apart. The environment setting for weathering by crystal growth must contain a source of salty water. Chemical weathering breaks down rocks one atom at a time. Let us look at an overview of chemical weathering.
Today. Now with chemical weathering, like I stated earlier, there's a change in the composition to the rock, and there's three ways in which this can happen: oxidation, carbonation, or hydration. A good place to check this out is in a graveyard. If you look at the headstones, very easy to tell what rock is resistant to weathering and what rock is going to be really less resistant to weathering based upon the clarity of the letters and numbers on the headstone. If the letters and numbers are really wiped out, you probably have a pretty soft rock. If you're still very legible and you can really read them nicely, probably have a really resistant rock. So the name of the type of weathering that we're going to talk about actually gives you a clue about what attacks the rock itself. So in oxidation, oxygen combines with the minerals and elements within the rock and produces a red rust color to the rock, a beautiful, beautiful red color. And the reason is because of the iron within the rock. The iron and the oxygen really attack each other, and it ends up being a very red, rusty color, much like the red rock in Sedona. Next type is what we call carbonation, and this is where carbon dioxide combines with the minerals and elements in a rock and attacks it. Specifically, there's a mineral calcite that gets attacked. What happens here is that you tend to get carbonic acid. The carbon dioxide dissolves into water and creates a very weak acid called carbonic acid that attacks the calcite in limestone and marble. Well, if you're given enough time, that rock gets eaten away and it creates features underground called caves or sinkholes. So here's kind of what a cave system might look like. And here's what a sinkhole looks like. And really what happens here is that the rock just can't support the overlying soil layer, and the soil just gets too heavy and caves in upon itself. Now the last type is what we call hydration. And this is when water is going to attack the minerals and elements within a rock. And really what happens here is that it turns very hard minerals into very soft substances. And a good example of this would be feldspar would be attacked by water in the hydration process to create a very weak clay. And that's what's demonstrated here on the right-hand side of this region's diagram. So those are your basic types of chemical weathering that you should have an idea about. Now realize that chemical weathering only happens in certain parts of the country, more prominent than others.
Most dissolution in chemical weathering is not performed directly by the water, but rather by acids contained in natural waters. For example, rainwater is not perfectly pure, but already contains dissolved carbon dioxide, which produces a weak acid called carbonic acid. Oxidation is a very common type of chemical reaction and also familiar to most people in the form of rust on old cars or other metallic surfaces. Many rocks that are rich in iron have reddish stains from rusting due to chemical weathering by oxidation reaction. Hydrolysis is a family of chemical weathering reactions that involve direct reaction with water molecules. When feldspar's in a rock weathered to clay, they typically expand slightly and can cause a tiny wedging effect on the surrounding crystals or grains. Biological weathering is the weakening and subsequent disintegration of rocks by plants, animals, and microbes. Plant roots can exert stress or pressure on rocks. Although the process is physical, the pressure is exerted by a biological process.
Root wedging, and this is very similar to frost action. Plants will grow out of the crack in the rock because there tends to be quite a bit of moisture in the cracks in the rock. There's enough water in there for the seed to germinate. Well, the bigger the plant gets, the bigger the root gets. The bigger the root is going to be, the bigger the crack in the rock. And eventually what happens? The rock will eventually break apart. And you can see here the tree growing out of the side of the rock there.
Burrowing animals such as rabbits or prairie dogs can burrow into a crack in a rock, making it bigger and splitting the rock. They also expose more of the rocks to weathering. Biological process can also produce chemical weathering. For example, when plant roots or microorganisms produce organic acids which help to dissolve minerals. In summary, there are three types of weathering: mechanical, also known as physical, chemical, and biological. In chemical physical, we have abrasion, ice wedging, exfoliation, thermal expansion contraction, and crystal growth. In chemical weathering, we have dissolution, oxidation, and hydrolysis. In biological weathering, we have plants, animals, and microbes. Make sure that if you missed something, go back and review it, because tomorrow we will have a quiz.